record. طيب. بسم الله الرحمن الرحيم. So now I'm going to start and I'll try to finish just admit and admit اللي هو the last part of the load calculation. Okay, so what we have here, as you can see, so what you can see here is as follows. We have a panel board. This is a panel board and it's connected to 4 different loads, and I want to calculate the conductor size, okay, for the conductor number 1, conductor number 2, conductor number 3, and conductor number 4. And as you can see, for each conductor we have what? We have safety breaker 1, and conductors number 2, which is going to be a cable, is related to safety breaker 2, as well as conductor number 3 and conductor cable number 4 for safety breaker 4. So what we need to do now, we need to calculate the conductor size, the circuit breaker for each branch circuits, as well as we need to calculate and figure out what is the main circuit breaker size and the service entrance size. Clear, Shabab? So this is what we are going to do now. In order to do that, we need, if you remember, I'm going to take it, like slowly. I'm going to work with load number 1, then I will move to load number 2, load number 3, load number 4. So I'm going to calculate the conductor and the circuit breaker for each load. After that, when I finish all of the 4 branch circuits, I will move to the main circuit breaker and the service entrance. So basically, we have like 2 parts of the question. The conductor, the branch circuit side or phase, and then the main circuit breaker and the service entrance side. Okay, so let's read what is written here in this question. It states that a panel board as seen in figure 1.1 is designed for an old building in an old area. Okay, so we have old building in an old area. So I am expecting that I will get line number 1, line number 2. So the line to line voltage will be 204. It goes without saying, I have to conclude it. The phase to neutral voltage is 120 volts. So in other words, this conductor number 4, I'm talking about load number 1 and load number 3 are related to 120 volts. Whereas load number 2 and load number 4 will be related to 240 volt. Why is that? Because here we have 1 live and here we have 2 lives, and it is old building in old area. So the power supply voltage line to line 240, sorry, line to neutral is 120. I got all of these information and concluded them from the question. It is supplied by a service entrance voltage 120 to 240 volt single phase 3-wire system. So also it is given here. The loads connected to the branch circuit breakers are also demonstrated in the same figure. Then calculate and fill in table 1.1. First of all, I need to find all branch circuit breaker sizes, branch circuit conductors, main circuit breaker size, the service entrance cable. And these are the circuit breakers which are available. Assume an ambient temperature of 330 Celsius. Why is that? Because later on, if you remember, we said we will go to the table. I believe this is the table. Just a minute. New share. Here it is. At the end, if you remember, we said we will go to this table for the first column in order to select the right conductor. Okay? So let's start with the calculation. I will go back here to the question and let's start with load number 1. So I'm going to write it like this: load number 1, load number 2, and so on. So here we have load 1. For load 1, what we have? We have the power supply. What is the power supply? Or sorry, the power, the load, the power at the load, it's 5 kilovolt ampere. So it is given. So it is given as 5 kilovolt ampere. So now I need to calculate what is the current needed by this load. So I can say for load number 1, the current needed equals apparent power divided by what? Divided by the voltage. Now, and this is equal to, Now, what is the apparent power? It is 5,000 kilovolt ampere divided by the voltage, which is 120 volt, and this is equal to 41 watt. Is going to be 41 ampere. So this load needs 41 ampere. So I'm going to say that the circuit breaker size, circuit breaker 1 will be equal to what? I will select it from, oh, this is one, just a minute. So I'm going to select it from the options I have it here. I have 15 up to 250. So the current is going to be 41.6 ampere. This load is going to draw 41.6 ampere. So I'm going to choose for sure 45 ampere. So the circuit breaker size will be what? Was going to be 45 ampere. Okay? Right. What about the conductor? Conductor 1. Conductor 1 will be what? Will be selected from the table. Conductor 1. Which table? We will go back to this table here, and I will look for 45 ampere. Now, we said we have to go to first column. We have 15, 20, 30, 40, and then I have 55. So either I choose the conductor side, the conductor size 8, and 8 is related to 40, and this one is related to 55. So which one I'm going to choose? I have to choose one of these, either 8 or 6. Since it is 41.6, then I'm going to go to 6. So the size of the conductor, number 1, is going to be 6 AWG because it's related to 55 ampere. So I will go back here to my question, and I'm going to write, so this one is going to be 45, sorry, what was it? I forgot it. It is 6 AWG. Okay. By the way, is it a continuous load or not continuous load? It is not mentioned here. To branch, also demonstrated, the calculated. If it is written that this load is a continuous load, then I have to multiply it here, multiply with 1.25 if it is mentioned that it is continuous load. Since it is not mentioned that it is a continuous load, so I'm going to go with this calculation. But if the load here is mentioned that it is a continuous load, then I have to multiply again with 1.25, then I will choose the circuit breaker, then I'm going to choose the conductor. So again, I'm going to repeat this one very quickly. Load number 1, it is 5 kilovolt ampere, the voltage is 120, so 5,000 over 120, this load is going to draw 41 ampere, 41 ampere, so I'm going to choose 40 and 45, I will choose the bigger, so it's going to be 45 because I cannot go to 40, it is 41. So it's going to be 45 ampere. Now, since the circuit breaker is 45 ampere, this is the circuit breaker, then I have to choose the conductor based on the circuit breaker. I went to that table, and in that table, let me go back to the table. Now, in that table, I found that I have 40 ampere and 55. Since the circuit breaker is 45, the circuit breaker is 45, then the conductor must be equal to 45 or greater than 45, which is 55. So I choose 6. Okay. Same thing will apply for the other loads. So let's go to load number 2. I'm going to put it here. So I will go here to load 2. Load number 2. Now, in load number 2, where is it? Here it is. It is 40 ampere. So in this case, the good thing that I gave you the current of the load, apart from the power. So I'm going to calculate the power just in case. So S is, because I'm going to use it again later on, S2 will be equal to what? It's going to be equal 40 times 240, and this is equal to 9,600 volt ampere. Now, what about the current? The current for this load, the current for this load already given, and it is equal to 40 ampere, okay? So what will be the conductor side? Conductor number 2 will be equal. Now, first of all, I have to go to the circuit breaker. So circuit breaker 2 equals, I will choose it from here. I have 40. We said the circuit breaker must be equal or greater than the load. Since the load will need 40 ampere, then I can choose what? I can choose circuit breaker 2. I can choose it to be what? To be 40 ampere because it is equal. Now, what about conductor 2? Conductor 2, I have to go, okay, no problem. I have to go to the load. Share, table, I have 40 ampere. So 40 ampere will be 8 AWG. So I will go here to 8 AWG and conductor 2 will be 8 AWG. So this is for load number 2. Now let's go to the other load, which is load number 3. Load 3. Now, it is given the power as 3.2 kilovolt ampere. So the current which will be drawn by this load equals 3,200 over the voltage, which is 120, and this is equal to 26.6 ampere. So this is the current. So what will be circuit breaker 3? Circuit breaker 3 will be equal, the current needed is 26, so I have to go for 26. I have 25 and 30, so I will go for 30. It is equal to 30 ampere. Okay, so this is for circuit breaker 2. Now, since the circuit breaker here is 30 ampere, so the conductor size will be what? I have to go to the table. This is the table. And I have to look for 30. 30 is 10 AWG. So back to the question. Conductor 3 equals, we said 8 AWG, if I'm not mistaken. Okay? Now, same thing applies for what? Same thing applies for load number 4. So let's go to load 4. Load 4. Now, the current. The current equals what? I equals. Now, we have the power, which is 12,500 volt ampere divided by 240. And this is equal to 52 ampere. So this load, as you can see it here, this load will draw 52 ampere. So the circuit breaker 4 must handle the 64 ampere, the 52 ampere, sorry. So we have to go to the selected value. We have 50 and then we have 60. Based on the available, circuit breakers, so I have to go to what? To 60. So circuit breaker 4 equals 60 ampere. Again, 52 ampere is needed and the available market 50, then it jumps to 60. I cannot choose 50, so I have to go to 60. Now, the last part is what? Is the conductor number 4, and this is equal. We have to go to the table. Here it is. Where the table? Here is the table. And I will look for 60. 55, then I have 70. So I cannot choose 55, so I go to 70, which is 4 AWG. So the conductor size number 4 will be what? Will be what? I forgot. I have very bad short-term memory. We said 4 AWG.
Yes.
عندي very bad short-term memory. So it's going to be 4 AWG. Clear, Shabab? So based on this, I calculated the circuit breaker based on the current. Then I figure out the conductor side. Same thing applies here. 40 ampere. I choose the circuit breaker to be 40 ampere. So the cable will be what? Conductors 4 will be selected to be AWAG. Same thing applies for load number 3 and same applies for load number 4. So what we have done basically is we went to the load, and from the load we figure out what is the total volt ampere power, right? From the volt ampere, we divided the voltage volt ampere over the voltage. We figure out the load current. From the load current, we calculated or we figured out and we selected the circuit breaker. And from the circuit breaker and using the table, the National Electric Code table, we selected the conductor size. So in this way, we finished the branch circuits. Now we have to go to the main circuit breaker. So what will be the main circuit breaker? For the main circuit breaker, so I'm going to put it like this. Now we have different methodology for calculating the main circuit breaker. Now main circuit breaker size. Main circuit breaker size, we have to know that the circuit breaker doesn't look at each breaker alone. It looks for the whole load. So we have to calculate S total. S total in this case is equal S1 plus S2 plus S3 plus S4, right? So it's going to be 5,000 kilovolt ampere plus open parentheses. For load number 2, what it was 9,600. 9,600, right? Plus the other load number 3, it is 3,200. Plus the last load, it is 12,500. And this is equal to 75,300 volt ampere. So again, the circuit breaker doesn't look at the total circuit breaker. I cannot say, well, this one is 40, this one is going to be another 4, this is 45, this is 40, this is circuit breaker 30, this is circuit breaker with 60, then I calculate the whole circuit breaker currents and then I will add it to circuit. It doesn't work like this. The circuit breaker at the end, the main circuit breaker is connected to different loads. So we have to calculate the load. This is rule number 1 in calculating the circuit breaker size. So I figure out what is the total ST, right? Now, the circuit breaker, the current total will be equal what? It is equal S total divided by V total, right? And this is equal, S total equals to 75,300 divided by what? Divided by the voltage which is applied by the main circuit breaker. Now, as you can see, the main circuit breaker is connected to 2 lives, right? So the voltage is 240. And this is equal to 313.71 ampere. So this is the main circuit breaker size. So I have to go to 200. It is equal to 300. Something wrong here.
You have a mistake. You wrote 50.
ايش هو؟
5 كيلو. For S total you wrote 50 kilovolt.
بدي اقول لانه مش طبيعي الرقم اللي طلع معي. Now it makes sense. Yes, it makes sense now. I think I have to delete one. لانه 5,000 9,000 3,000 12,000 طلع عندي 75,000 يعني مخي وقف. هسه بصير 75,000 وايش 12 و3 و9 برضه في
30,300 التوتال 30,300.
وين الخطأ تبعي؟
انت كنت حاط صفر زياده فانت حسبتها زياده طلع لك 75,000 كان المفروض 30,300.
شوي 30,300. اوكي هاي بيطلع عندي ايش؟ ان امبير سوري فولت امبير. 30,000 وهون بده يصير عندي 30,300 30,300 تقسيم 240 شو بيطلع لنا الكرنت؟ اوكي 126.25 ايش امبير. So this is the current which will be drawn by the whole load. So based on that I will select the main right circuit breaker equals 2. So I have 126. So 126, 110, 125. So I will choose 130, right? So this one will be 130 ampere, right? So this is the main circuit breaker. Now from the main circuit breaker, I need to calculate what? I need to calculate the service entrance cable. This is the main service. شو المشكلة هنا بسيرفيس؟ I service, I entrance cable will be equal. What is the size of the service entrance cable? I'm talking about these 2 wires. So I have to select from 130. So I need to go to the table, share 130, 125, 145, 2 over 0. So it's going to be what? 2 over 0, share 2 over 0 AWG. 2/0 AWG. So this is the size of the main circuit breaker. Clear, Shabab? So in this way, I calculated the branch circuits, what is the circuit breaker of the branch circuit and the conductor for each branch circuit and circuit breakers. Then I have to calculate the main circuit breaker and what is the main service entrance for the service breaker. Clear, Shabab? هيك clear؟
Yes, clear.
أنا بالنسبة لي أنا هذا الموضوع اللي الآن بهمني إنكم يعني to understand it.
Very clear, teacher. Thank you.
خلاص. Okay. So now I will say that I concluded the whole class for you. Inshallah, the load calculations are finished. With other material, I think it is clear for you. And I hope, inshallah, you all the success in your final exam, which is going to start next Sunday. Starting from next Sunday to the other Sunday. Okay?
Inshallah.
inshallah. حد عنده سؤال because I want استنى هون في عندنا admitted. Okay. حد عنده سؤال before I stop recording؟
عندي سؤال يا أستاذ.
تفضل.
بالنسبة لو قال اللود continuous وش اللي أضربه في 1.25؟
يعني مثلا نفترض load 1 is continuous. This is load number 1. So load number 1, I will say the current will be S over V, and then I have to multiply here, somewhere here, I have to multiply with 1.25 times هذا الرقم if it is continuous.
اوكي يعني الكرنت اللي نضربه في 1.25
بالضبط هذا الكرنت must be multiplied with 1.25.
طيب واذا كان اعطاني شو اسمه الكرنت دايركت مثلا زي اللود الثاني
هيا اللود الثاني
divide 1.25
برضه بتضرب اذا كان continuous. قلت لك ان اللود 40 امبير but the load is continuous so you have to multiply with 1.25.
Okay, ممتاز.
Load where is load? Here it is. Load number 2, it is 40. I have to multiply with 1.25 if it is mentioned that it is continuous.
Okay.
Clear? طيب في تريك اخير ما بعرف اجيبه ولا لا بس يعني للعلم او حتى لكم يعني في حياتكم العمليه انه مثلا what if this load is a 3 phase يعني هون عندي كان اللود كله single phase. What if I have a 3 phase load, okay? And I have one branch circuit مثلا هذا central unit AC unit and it's connected to 3 phase. فهمت علي كيف؟ فساعتها ساعتها شو بده يصير في عندك؟ انه بدي اخذ نفس هذا اللود نيجي على هذا اللود افضل. ان اللود هذا اللود عباره عن 3 phase. It is not single phase 2 wire system. It is 3 phase load. اللود 12000 12,500 كيلو فولت امبير. So what I need to do what? I have to calculate اللي هو مثلا خليني just a minute. I'm going to assumption. Okay. Just a minute. Assume load 4 is a 3-phase load. Okay. هنا في عندنا S أنا عندي مشكلة في الكيبورد بس يعني سامحونا. Assume load 4 is a 3-phase load. فهمت علي كيف؟ With S equals خلينا نقول 12500 زي ما هي فولت امبير. اوكي الفي لاين تو لاين given as what اللي هو 280. نفترض هناك اجاني السؤال. It is a totally different question. So it is 3 phase, the power is 12,500 and the voltage is 208 line to line. So calculate blah 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 القصص هاي كلياتها. So if we need to make the calculation we need to start with what? We need to start with the current, right? So the current I will be equal to what? The current equal S divided by what? Divided by square root 3 ضرب مين؟ ضرب ال V line to line صح ولا؟ سكر قوس اللي هي خلينا اكتب لكم اياها هيك ink math to ink just a minute. بده يطلع عندنا الكرنت equals equal يا محترم equals بده يكون في عندي هنا اللي هو اس توتال لانه 3 فيز تقسيم جذر الثلاث اوكي في في لاين تو لاين في لاين تو لاين مش 2 ل 2 بس خلينا اقيم هذا الهبل. طيب كلير اوكي اسف رايت مره ثانيه اي انتوا فهمتوها علي؟
اتس
equal
كلير تيتشر.
ايوه اس على اللي هو بالضبط خلص ما دام كلير ممتاز. اذا اس على سكوير روت 3. ليش في عندي سكوير روت 3؟ لانه ايش؟ لانه جذر لانه
3 فيز.
لانه 3 phase system. احسن. So in this case will be equal to what? In this case S total اللي هو 12,200 500 عفوا 500 divided by اللي هو نفس الشيء سكوير روت 3. راح اجي اكتبها هاي كلياتها نفس الشيء.
روت 3
روت 3 اللي هو 1.7 اظن صح؟ 1.7
ملتبلاي في لاين تو لاين.
ايوه ضرب اللي هو اللاين تو لاين قلنا 208
208 يس.
سكر قوس and this is equal to بعطيه قديش 35 امبير. سو عرفنا قديش الكرنت 35 امبير. هون بنيجي بنختار اللي هو 35 ما في عندي 35 point something. اذا بختار ايش؟ بختار 40 امبير. فهمت علي كيف؟
يس.
بختار 40 امبير. اذا بيطلع عندك circuit breaker for 3 phase system. يعني لازم نجيب السيركت بريكر 3 phase equal قديش قلنا؟ اللي هو 40 امبير. 40 امبير. هسه بتروح على التيبل بتختار شو ال 40 امبير. اظن شفناها ال 40 امبير واحده من الاسئله. هاي ال 40 امبير يطلع 8 اي دبليو جي. 40 امبير. اذا كوندكتورز او كيبل هون بصير كيبل 4 equals ايش قلنا؟ 8 اي دبليو جي. 8 AWG صح؟
Yes.
Clear? If I
Clear.
mentioned assume load 4 is a 3-phase load, if it's a 3-phase continuous load, if I added continuous, then you have to multiply here with what? يعني هذا 35 تضربها ب 1.25 لأنه الكرنت تضربه ب 1.25 بتكمل الحسابات بس. تمام؟
اوكي تمام.
بس ما في أكثر من هيك. Questions?
ثانك يو.
Any question؟
تمام يعطيك العافيه استاذ.
طيب خلينا أطفي التسجيل. أوقف التسجيل أقل شيء.